6-week course in Swan if you don't have the background to go there. You know, so nobody, they don't hold back. Because I did a couple of factory training, but it wasn't for this. My factory training was ice makers.
That's why you always talk about ice makers.
Right? And you know, it's the same. And you know, the reason I went and do the ice machine training is because I get it like half price.
Yeah.
Because I deal with United Refrigeration there in Asia, and I know all the goddamn people from the factory. So, you know, I get a deal. That was in Wisconsin.
Oh, Wisconsin.
And stupid me, I signed up for a class in the middle of January.
Yeah, that's nice.
Why? What's the matter with January?
It's snowing like that.
Okay, it wasn't snowing, but in the morning when I wake up to go to class, the temperature is -10. High temperature at midday, -5. So I'm still below 0. You imagine, at that time I used to smoke. You come out the facility to smoke the cigarette gets frozen.
That's how long it's going to be.
You were in the training facility and one of the electric poles explode because the place was so cold. So, yeah, these guys, you know, once they you finish that training, you're going to get a certificate and you can get a job with people who do supermarkets. You know, there's a refrigeration company, I'm pretty sure you see their van driving around AAA.
Yeah.
And there's Tomco. These guys do a lot of this, you know. And none of their guys are really certified for it, but they give them, you know, they send them out with the techs who normally work in this, and they train that way. Those guys have some good technicians, you know, people who work with Tomco on this, because I know those guys, you go out there, they're willing to train you. All right? Even though you had the schooling, they're training you how to do things, you know, how to get used to in the real war situation. And here's the deal, you screw up one time, right? Either to somebody throw you off of the roof or you get fired. Well, if they throw you off the roof, you ain't good for anything anymore.
And you're fired on the way down.
Yes.
Yeah. Before you land, you're fired.
Because some of those guys, you think some of these idiots that destroy this class
No.
Is macho?
No.
Or stupid? No, some of those guys will be chew them out, you know, chew them up, spit them out.
I've worked with some mean
We did all this, right?
Dan, you got that, hold on.
Yeah.
What was that last one?
Go back.
Yeah.
Go back a little bit, mister. Oh, yeah. Stop.
Remember this is where we had the refrigerant leak detector. They have a central monitor unit, and these are little tubes that go to different parts of this structure.
Mr. Go back to the writing, please. 2 seconds.
Yeah, I got it.
Yeah, so what it does, there will be at strategic location, there will be these little tubes with strainers and some little like cotton ball around it so it won't get dust. And that unit always keeps sucking in air and sampling that air. It's like a snake sticking its tongue out. So always sampling that air, and the moment it sniffs any refrigerant, it sets off an alarm and it tells you what general location it is leaking. Because again, it's a supermarket and you have customers in there. You're not going to smell the refrigerant, number one. What's going to happen, you'll probably see people start collapsing. Because refrigerants displace oxygen. All right? And you know, it's colorless, it's odorless, and what else less? Tasteless. Like,
all the good things.
Honestly, I ain't gonna taste that. You know. So this is, you're still writing down?
No, it's good.
So this is the holding. This is a bigger version of those small electronic leak detectors we have in the lab, or we should have in the lab.
Yeah, a little
All right?
stiffer.
Because when you turn on those, you hear they go beep beep, and then you hear a little motor start pumping. That's actually a compressor that's sucking in air through the sensor tip. And on that sensor tip, there's a little heated diode. And as soon as it senses refrigerant come across that diode, it
But do they make things like specifically for certain refrigerants? Because a lot of the stuff that I see is specifically for this refrigerant or that refrigerant.
but,
You know?
no. You probably will have, that's not like something generic that you get, that they make every day.
Yeah.
Because the average technician would like to buy one tool that can
Yeah.
sense multiple
Yeah.
refrigerant. Because I'm not going to stock like 10 different test equipment in my truck. That really does not make sense. It's just going to take up space
And money.
and money.
Limits you.
Yeah, and it limits you with the amount of parts you can stock, you know. I have 2 trucks and they're filled with just purely refrigeration parts. I can't do anything else but that. And if I stick that testing, 6 testers to test 6 different refrigerant, what can I have it? You know? I even stopped buying all these fancy refrigerants they have out there. I kind of narrowed down now, and I'm using like 4 different refrigerants for everything.
134,
134, 404, and 407. And I'm done. 410A, that's a different ball game. I don't. And
Residential.
yes, that's for the new air conditioner.
Yeah.
And unless I'm going out to service air conditioning unit, I don't even have that in my truck. So they're all kept in the shop and they're safe there anyway. So always have different sensors, different locations in the store. You actually will have the sensors in the walk-in too. Typically, you may see one of those sensors right where they have the expansion valve, because for some reason that's about the general area where you always develop a leak. And it always happens in a nasty position where you get a big headache while you're trying to braze in the hole shut. Electric expansion valve. Did I ever show you guys electric expansion valve?
I don't think you brought one in, but
All right, I'm going to show you the electric at the break.
Yeah,
I'm
you're
gonna
supposed to
go-
bring in I think you're supposed to bring that in and something else today. What you say you're supposed to show us?
We're gonna bring in some kind of,
something.
Yeah, some things it was going 3 things.
I'm gonna start.
Electronic expansion valve and some kind of box, you said?
All
maybe it
right.
would be ROAC or something like that?
OROA.
ROA, what are you gonna bring in?
RTD, I don't know.
You said
For the
yesterday.
electric expansion valve, I'll do that first and then I remember. My brains are going. When you get to my age, you'll know what it feels like to forget stuff.
Mike's gonna
I'm right
So-
there with you, brother.
Amen.
Yeah, me too.
Hold on now, yeah. You making babies.
But guys, when we get into this realm of the system, when we start using electronic and electric stuff in there to control the temperature, one of the things it always will have is a controller board, master controller board, and instead of having, my normal expansion valve, there was one.
It has the bulb on it,
The bulb.
It has a sensing bulb.
it has a dimension.
These do not have a sensing bulb. There's nothing thermal about these valve here.
So-
It is a valve and valve only,
And temperature.
right?
So
It comes with
Dimension.
it has 4 wires coming out, which is red, black, white, green. These valves are what we call they have a bipolar motor to open and close them. It's not done by pressure developing a bulb, right? So this pair of wires will open the valve. This pair will reverse the valve to close it. Okay, and that valve modulates down to like 1 degree of superheat. Once we have that, we now have thermistors to sense temperature. Thermistors are temperature sensing resistors, which they have positive temperature coefficient and thermistor or negative temperature.
Now those go back to the master control.
Yes,
board,
everything goes into the master
all
controller.
the wires.
All right, and positive temperature thermistors, as the temperature increases, the resistance increases.
Yeah.
Negative temperature thermistors, the resistance decreases, temperature decreases. Or as the resistance increases, temperature.
That's how
Same
it
thing.
sends it back to the control board.
Yes, but everything has to go to that master control board. And you will, in DDC, you will see a lot this I/O, which is input output.
Yeah, yeah.
So we have all of these. Pressure transducer is a piezoelectric base module that is screwed into the pressure line to the pressure port, and that generates a signal that's sent back to the board too.
It's all good to know.
So the board now translates that pressure into a temperature, and it translates this resistance into a temperature, and then it tells this valve where it needs to go to feed either more or less refrigerant as needed. Okay, but bottom line is though, it's all based on superheat still, because it is a direct expansion
But
evaporator, so I do need to have an established superheat at the outlet.
yeah, but
Alright.
it's nothing that you set. You set it on using the control board.
Yes, I can set it from 1 to 20, 30, 40, 50.
50.
No, I can't set it to 50.
I didn't think so.
There is a limit to how much you can set it. You know?
But in other words, you set the valve with the superheat that you want.
Yes.
You can set
You set this, not the valve, you set the controller board
Well,
to the
controller
superheat.
board and then the
And the
valve.
valve, you set your room temperature and you set your superheat. And the controller board reads everything and do the rest for you.
Right.
It's kind of foolproof and it works great, guys. Those are room. If you imagine you have a freezer, you probably will see this thing. And one of the reasons why you really should be wearing work boots when you're doing refrigeration is because with some freezers, inside that freezer is so dry that as soon as you step in the door, your boot sticks to the floor. And when it says stick, it's stick like if there's crazy glue there. And a lot of time, I have boots like this, and you walk and the boots stay down there, and you put your other foot, your foot in the socks there, and you kind of want to stick to. The socks will save you a little bit of time for you to pull it out. And then you hop out with one foot. Like you play hopscotch. So,
The
you
freezer
gotta be
says we
absolutely
should.
careful. Freezers dry out everything, guys. And if you touch something, chances are your hand will stick there, and when you move it, it peels the skin off.
So it's like that when you stick
That's
on the
like
TV
it.
show and they put their tongue on the pole.
No, it's not. It's when a little kid put his tongue on the
Christmas
pole.
story?
Yeah,
Christmas
yeah.
story.
Yeah.
That's how it is.
Yes, that's how it is, and it's dangerous.
So you gotta wear gloves then too.
So always wear protective clothing in a freezer.
I did that before.
Alright. I mean, I don't know how many of you guys would be working in negative 40 degree temperature, but I tell you, you can't spend much more than 5 minutes in that.
No, you have to have a freezer suit.
Yeah, what we used to do is tag team. One person will go in and locate where the problem is and make a note. The other person will go in and see what tools they need. Then the other person will come and see what parts they need. You know? That's why we have to tag team, because you can only spend 5 minutes and maybe get before your person. Even though you have those stick Eskimo thing,
Yeah.
yeah. And man, we used to, that was the one part we used to dread. Going into the freezer, deep freezer, that's at that temperature.
Let's go.
But they do keep, they do have freezers that are at negative 40, not to stay there. That's when they're doing food
Blast
processing. And you guys, if you go to the supermarket, you can buy a package of green peas or any kind of vegetable. And each of them in that package will separate, even though they're frozen rock hard. But if you put that same peas fresh in your freezer, the whole, when the bag comes out of your freezer, it's like one solid
Block.
block, right?
Yeah.
So
Freezing over time.
that's because with your freezer it takes longer to freeze, therefore all the ice now build up and make one big ice bubble instead of individual tiny crystals. So the faster you freeze it, the smaller the ice crystal so it doesn't damage the product. In this instance they call it IQF, individual quick frozen, for packaging. So each separate out as you want it. Like if you go buy shrimp, 2.5 pound package, but you only need 1 pound to use because your wife leave you and went away. So you have to cook for yourself.
Yeah.
You can take out half and you can take them out individually. They're not stuck to each other. So that's how, at -40, it allows me to do that because you only stay there. Most products only stay there between 25, maybe 30 minutes, and they come out rock hard. And you see they're high-speed packaging because when they come out, they shoot at somewhere around 60 to 80 miles an hour into the box. All right, and small as a CFP, if that comes at 280 miles an hour, it's going to hurt something really nasty. You don't want that. So that's how they package all those little things, call it individually quick frozen, and at that temperature. Like I said, have to be absolutely careful when you work under those conditions.
Yeah.
Super nasty.
Oh yeah. So the controller directs it. Now these controller guys, you can program them from any computer, anywhere in the world. All you have to do is install what the manufacturers call an optional modem, which will cost something, of course. But you can actually go to the board itself and program it from there too. All right. For those of you guys, maybe you live somewhere out in Cora. There's a McDonald's right by Route 112, 125.
Right by Home Depot.
By the Home Depot.
Home Depot's there.
The free, I don't know if you go by, when you come around by the drive-thru and you look to the building, you see a freezer attached to the side of the building. Actually, it does not look like a freezer. It looks like part of the building. But it is a freezer I installed here in 2006. September. Was it September? September, yeah. Yes, I remember beginning to get chilly. September 2006. And it has one of these systems. We call it the beacon system. McDonald's call it Mac 6 or Mac 7. Because they have to put their name to every damn thing.
Yeah.
Yes. But it has everything you read about here. That's what it has. Right? And I can program that direct from the board. And along with that, I have a programmer in the manager's office with a display too. And with an optional modem, I can hook up that system to the internet that you can access from anywhere.
You can program it from your couch.
Yes, and you can change temperatures, you can read out what happened in the last 24 hours, for 48 hours, however, whatever information you want, you can get from that system. And that's my electric expansion valve right in there. You guys recognize this, right?
Yeah, distributor.
Yeah, that's distributor.
Distributor.
I was working on that bastard yesterday.
You know the reason we have multiple refrigerant circuits, right?
Yeah.
Yeah, to give them an even even flow through every.
Yeah,
area.
so that we don't have pressure drops.
Yeah. No pressure drop.
Alright, so.
That's a styrofoam strap between the two, no? This is styrofoam, right?
See, that's my pressure transducer. If you guys check that condenser unit for
We
the,
saw it yesterday, we were talking
for
about
the
that.
walk-in box there, it has a pressure transducer on the discharge side.
Yeah,
We
but
can't
they
use
lost-
it.
Yeah,
We can't use it with no plug.
The elastic
They
cable,
lost
right?
the plug.
Yeah.
Yeah. So
Yeah, there is a-
we're putting
No pressure control.
There's a 3-pin plug
Yeah.
for that because you have that cable has to be long enough to go, and not really long because typically where this valve is and that they're in the same area in the side cover here is where they put the controller. So you have the display board here where you can program everything. So it's just a matter of going from here to here. And this. And by the way,
What's that? That's a piece of styrofoam they have strapped between there?
here,
Styrofoam, yeah, right there. What's
yeah, to keep this from shaking. You don't want this whole thing to vibrate. All right. See, you can shake that a little bit. You can start with some vibration. The vibration, if you have vibration, you see all these brazen points.
that? Yeah.
It will tend to crack.
Because
And-
it's so cold or because.
Well, it's
A mixture.
number one is it's cold. It's going to be brittle, and then the vibration. You will get a crack. And it can only take so much of vibration before it decides to fail. And you do not have to, you see how they have this wrapped up here? You do not have to leave that wrapped up before you connect it. It's okay, you can cut that wire.
Okay. Sure.
You know, regardless what any book may tell you, I doubt this book says that to leave the wire that length, but regardless what any book tells
So
you,
you just cut it and splice it?
I will, no, you're gonna, if this is a controller board, this is the valve, and I have 10 feet wire coming in, I'm gonna cut it to suit this.
Yeah,
Yeah.
I'm saying, but you cut it and splice the wires together, or you?
No, it goes into the board in a terminal block.
Yeah.
So all you do is cut it and strip the
Slip
end.
the ends and put it in
Oh, okay.
it goes in the
Right,
wire.
put it. In this case,
I'm saying, because it looked like you had a plug on each end, that's
Yeah.
why.
That's it, that's it. Right. So three of them, right? 1, 2, 3. That's a plug, that's a plug.
well, in this case, they probably had this remote someplace else.
Okay.
But
Because-
most of the time, this is here because whenever I have to program these, it's better to have this because I can have my hand on it while I'm programming that board. And when you have your hand on it, you can feel what it does.
Right.
All right, you can feel the movement.
Oh.
And I don't really want to, I can't tell the difference if it's going to move to close or move to open, but I need to feel that movement. Because if I put it to open and I feel movement, then definitely it will go into the open position. And with that, because you're so close, you can hear the refrigerant
Yeah,
starting
go
to
in.
flow through.
Yeah, and you can feel it.
And you could feel the difference in temperature too.
Yeah.
So, you know, it's easier here. But if they have the Molex connectors, they're fine. Use the Molex connectors. All
And
right?
you
Try
can
not to
20
splice.
feet away.
You know?
Now that thermistor over there, that's also goes to the control board,
Yeah.
right?
Yes,
That's
everything,
wired
because
plugged in there too.
here's, this is the thermistor.
Yeah,
Yeah.
and there's a wire right underneath that looks like.
Yeah, this will go to the controller wire.
Board. It should be.
All right?
The black piece, that's that. The piece which is, see, there you go. See,
These are all of
there you
them.
go.
That's the
Okay.
control. Where's the control?
That's all your connectors.
Well, what's the thing up there with the LCD screen?
That's a BlackBerry, buddy.
We're gonna see,
That's your computer.
that's a BlackBerry. You can have an app,
That's your computer, buddy.
and
In the back.
it's in the back there. Oh, look at here.
So that's the EEV right there.
Yeah, this is my electric expansion valve, pressure transducer, thermistor, control module.
Where's the infrared device for?
Temperature.
No, what this does, in some cases, it looks for buildup of ice at the back of the evaporator.
Okay.
Okay?
This is a really smart system.
I'm
Yes.
you, bro. You see that shit?
When we get into ice machine, remember this, some ice makers have an infrared sensor to sense the level of ice in the bin. Actually, Scotsman is the only ice maker that has it.
Man, alright.
Bro, the thing is, man, I think the cafeteria available now. Can't hear.
Did you
Can't
guys,
hear
when you guys were doing motors, you heard about this?
No, I never heard about it.
Electronically commutated motors. They use less energy. One of the things with these motors is that as the load increases, it ramps up to maintain.
They ramp up and down, right?
Yes.
Almost like a VFD they use.
On-
Right?
Yeah, it behaves just like if you have a VFD in this. But as you increase load, what happens? It maintains constant torque, so it doesn't drop any RPM. Because if you add more load to a fan, you evaporate a coil, and the fan cannot compensate, it's going to slow down. Slow down with restricted airflow or less airflow. Less airflow translated into less heat being absorbed. Less heat being absorbed translates into lower evaporator saturation temperature, which translates into more ice formation in a shorter period of time. So we don't want that. See, much as we have defrost, you don't want to activate that defrost for more than 4 times a day during the summer and 3 times during the winter. Excessive defrost will kill your system and your product. And that's, do we have any in this? I think they have some, I think I see some in the electric lab.
And the next one be less speed.
Evaporator fan.
And less energy, be less speed.
That's speed.
Yeah, right underneath double engine.
LEDs, all those little light, fancy light you see, like, you know, in the cars nowadays for the headlight, they have LED lighting, they have you. They start putting these instead of fluorescent lamps in display cases, they start using these. All right. One of the good things about this, guys, it's easier to change out because they come in a module, maybe like 6 lights on a strip. And you don't have that many things to play around with. With a fluorescent light, you have the ballast, you have a starter, and you have the lamp tips. Those can go bad, other than the bulb going bad.
Right? Don't they get hot?
No, they don't really.
Like incandescent.
Fluorescent lamp don't get hot. They're incandescent bulb.
Incandescent.
All right. And these last way longer because not all fluorescent lamp can work at temperatures below 65 degrees. So if you happen to put the wrong fluorescent tube in a box that you're maintaining at 38 degrees, it ain't gonna last long.
And then when those are the ones that pop, the fluorescent tubes.
Well, they do make fluorescent lights and regular light bulbs for this application, which is what they call shatterproof.
Yeah.
If the glass breaks, it stays in a plastic.
Yeah, they got the wax.
It's them for work lights too.
Yeah, so it is made for use in a food service area. Okay? And these look nice. They make the food look good. Even though it may not taste good, they make it look good. if you guys ever go by a restaurant named H2O in Smithtown,
Yeah, wait, H2O?
yeah, in
Oh.
Smithtown Main Street, you will see they have a wine cooler by the waiter service station. They had, these were the lights we put in there.
Oh.
That was actually a look. We built that cooler and installed a refrigeration system and the lights everywhere. So it was locally
Yeah.
in-house building. Looks great, if I may say so myself. Yeah, looks damn good. You won't believe, you know, you believe it came out of a factory, computerized build. Alright?
Came out built out of the factory.
Yeah, like if a computer designed it.
What's in that cage right there?
Ooh, ice cream.
Food.
Looks like ice cream.
Probably ice cream mix. You mean these?
Yeah.
It's ice cream, I think.
Yogurt?
If you look from here, I think the ice cream contained it.
Yeah.
They probably look like soft. The mix that you use is soft serve ice
Soft
cream.
serve?
Yeah, that you put in the
It
machine.
looks like Edie's or Turkey Hill.
And you know, I tell you.
This guy knows his ice cream, right? It does look like, the first one looks like Turkey Hill, right?
Yeah, you know Edie's. You know what? Could be Edie's. You know?
I'm all for ice cream.
It ain't Haagen-Dazs, I'll tell you that one.
I love ice cream because whenever I fix the ice cream machine, you know they come in vanilla and chocolate flavor. I have to quality control the machine. I have to see if the vanilla part work and if the chocolate work and then if the swirl work.
Hold on.
Now, remember some time ago we talked about secondary refrigerant?
Yes,
Yes.
water and glycol.
Water and glycol, it's a mix. Depends on what temperature I want to go
46.
with. I will know.
But how
know
much
the mix.
glycol you're gonna
Yes.
need to mix.
You see, most of the time, you will call up the supplier and tell them, hey, this is the temperature I want to hold my glycol at, and they will pre-mix it for you. If we mix it out here, one of the things we got to be careful about, the water we get from the tap, it has a lot of impurities and it can cause rust in the pipe.
You wanna use distilled water?
Not even distilled water now will cause electrolysis.
Okay.
All right? We don't want, electrolysis is where you get eddy currents, electrical currents, and it's going to start chewing out the pipe or whatever it is. For those of you guys who have both, you know they put these sinks on them, the zinc.
The magnesium or something like that?
It's
Zinc.
actually zinc.
Zinc, yeah.
It makes it
That's
carbonate.
to prevent electrolysis in your boat engine, what have you, all the metal part. Yeah.
Both.
For the
Because-
bond ship too, to keep it.
Zinc could make galvanized pipe too with the zinc
Yeah.
outside.
So what that does,
It's a rust inhibitor too.
Yeah.
it creates, instead of the electrical current eating out your pipes and so with the glycol, it has something else that's more reactive and that will get chewed out. But we have to be careful about mixing the water. It's gonna, the very thing that you're trying to prevent is what you might create there, which is rust in the system.
Yeah.
And when you have rust, there's potential for leaks. And when you have a little leak, you can get into a bigger leak. You don't want that. Now these pumps, and I give you I have to do this for you guys. Can you flip that light switch for me? It ended up right there. It's 5 minutes more.
And I needed English.
So you got one.
And I couldn't
Now,
speak in Portuguese.
guys, let's say for example, you go to a supermarket with this system, and you're pumping glycol to 4 different cases, different sizes. Okay, let's imagine it's at the same temperature, but that case, those 2 cases may be the same size, and you have 2 more here, half of the size of these 2, right? So I'm gonna have 1, 2, 3, 4 cases. And we have 2 more minutes to break. After the break, this is going to take some time to show you guys. It may take about 5-10 minutes to explain that whole concept. So we're going to take the break about now.
Alright.
And we'll be back there like 10 and I'll show you guys.